In the vast cathedral of space, discoveries rarely announce themselves with fanfare. There are no sirens, no alarms, no dramatic moments when the universe reveals its secrets. Instead, truth arrives quietly, a single anomalous data point buried in terabytes of astronomical observations, a pixel slightly brighter than it should be, a trajectory that doesn't quite match the predictive models. On March 14, 2024, an automated tracking system at the Pan-STARRS Observatory in Hawaii flagged something unusual. Not a supernova, not a known asteroid, just a speck of light moving through the constellation Orion with motion that seemed deliberate. The initial classification was routine: probable long-period comet, distant trans-Neptunian object, or perhaps another piece of interstellar debris passing through our cosmic neighborhood. But as more observatories locked onto the object over the following weeks, the classifications began to unravel. It wasn't outgassing like a comet. It wasn't tumbling chaotically like an asteroid. Its surface albedo was too uniform, its trajectory too smooth, its motion too calculated. Scientists labeled it 3I/ATLAS, the third confirmed interstellar visitor to our solar system, following the mysterious Oumuamua in 2017 and Comet Borisov in 2019. Oumuamua had changed everything. That cigar-shaped visitor had sparked debates about alien technology, ancient probes, and the possibility that not every object drifting between the stars is natural. Its unexplained acceleration, its unusual shape, and its rapid departure left humanity with more questions than answers. For years afterward, astronomers waited, wondering if we'd ever receive another visitor from the cosmic void. 3I/ATLAS was the answer to that waiting. But unlike Oumuamua's brief flyby, this object moved with disturbing patience. It didn't accelerate wildly. It didn't tumble through space like debris. It glided through the darkness with the calm precision of something that knew exactly where it was going. Too symmetrical, too deliberate, too calm. As months of observation accumulated, a consensus emerged among astronomers who'd spent careers studying celestial motion. This wasn't behaving like any natural object they'd encountered. The smoothness of its path, the consistency of its velocity, the absence of any rotational wobble. Every characteristic pointed towards something that defied conventional classification. And then came the moment that changed everything. The moment when the James Webb Space Telescope turned its unprecedented capabilities toward this enigmatic visitor. The moment when humanity's most advanced observatory focused on 3I/ATLAS and detected something that shouldn't exist. This time, the universe didn't send a rock tumbling through the void. This time, it sent a message. When orbital mechanics specialists at JPL began reconstructing 3I/ATLAS's entry vector into the solar system, they encountered something that violated every principle of random celestial motion. The object hadn't simply wandered into our cosmic neighborhood, and it had navigated. The trajectory analysis revealed precision that bordered on the impossible. As 3I/ATLAS descended through the outer solar system, it had threaded a path that avoided every major debris field, every concentration of Kuiper Belt objects, every potential collision zone. More remarkably, it had executed a series of gravitational assists, using the mass of Neptune, then Uranus, then Saturn, with an efficiency that would make human mission planners envious. Natural objects don't do this. Comets and asteroids follow ballistic paths determined by their initial velocity and the gravitational fields they encounter. They drift, tumble, and occasionally collide. They don't execute optimal fuel-efficient trajectories that maximize gravitational assists while minimizing travel time. They don't navigate. Dr. Sarah Chen, a trajectory analyst at NASA's Planetary Defense Coordination Office, ran the simulations hundreds of times, each with slightly different initial conditions. The results were always the same. The probability of a random object naturally following this path through gravitational assists was approximately 1 in 847 trillion. Those aren't odds. Those are impossibilities dressed up in statistical language. A natural object drifts, Chen noted in an internal memo that was never meant to be leaked, but inevitably was. This one steered. And it steered with precision that suggests either extraordinary coincidence or extraordinary intelligence. The path revealed even more disturbing details upon closer analysis. Each gravitational assist had been timed perfectly to occur when the planets were in optimal positions relative to each other, configurations that only repeat every few centuries. Either 3I/ATLAS had been incredibly lucky in its timing, or something had calculated these planetary positions in advance and planned accordingly. Even more unsettling was the efficiency. Human spacecraft lose velocity during gravitational assists due to imperfect approach angles and atmospheric drag. 3I/ATLAS gained velocity with near-perfect efficiency, as if every approach vector had been calculated to extract maximum kinetic energy from each planetary encounter. The physics worked, but the precision required pre-planning on a scale that staggered the imagination. Scientists began using words they'd been trained to avoid in peer-reviewed papers. Words like intentional, engineered, guided, and the most forbidden word of all, piloted. Conference calls between observatories took on hushed, almost conspiratorial tones as researchers shared data that contradicted everything they thought they knew about interstellar objects. The most haunting observation came from the Hubble Space Telescope, which captured 3I/ATLAS as it passed through Jupiter's shadow. For 17 minutes, the object was completely occluded from sunlight, invisible in the darkness cast by the solar system's largest planet. When it emerged on the other side, optical analysis showed it had maintained perfect trajectory alignment. No drift, no deviation, no course correction. As if it had rehearsed this exact route through Jupiter's shadow countless times before, as if it knew precisely where every planet would be, where every gravitational field would tug, where every shadow would fall. As if it had been here before. Or as if something had mapped this route eons ago, when humanity still huddled in caves beneath stars they couldn't yet understand. On September 3, 2024, the James Webb Space Telescope completed its realignment procedures and turned its unprecedented observational capabilities toward 3I/ATLAS. What happened next would fundamentally change humanity's understanding of what might exist in the darkness between stars. Webb's infrared sensors, designed to peer through cosmic dust and capture the faint heat signatures of the universe's earliest galaxies, locked onto the object with crystalline clarity. Data streams immediately lit up mission control displays like digital Morse code, each packet containing information that shouldn't exist, characteristics that defied conventional interpretation. The first anomaly appeared in the thermal imaging. Natural objects in space, asteroids, comets, even spacecraft, emit infrared radiation in patterns determined by solar heating and internal temperature gradients. These patterns are chaotic, irregular, influenced by rotation, surface composition, and distance from the sun. 3I/ATLAS showed something entirely different. Rhythmic heat emissions pulsing with the regularity of a heartbeat. Every 147 seconds, the object's surface temperature spiked by exactly 3.7 degrees Kelvin, then returned to baseline, not approximately 147 seconds. Exactly 147 seconds, measured over hundreds of cycles with atomic clock precision. The thermal pulse was concentrated in specific surface regions that formed geometric patterns when mapped, hexagonal clusters that suggested organized structure rather than random geography. Spectroscopic analysis revealed the next impossibility. Webb's instruments can identify chemical compositions by analyzing how objects absorb and reflect different wavelengths of light. 3I/ATLAS's spectrum showed metallic compounds, iron, nickel, titanium, but arranged in layered configurations that mimicked manufactured alloys rather than natural mineral formations. The reflectivity patterns suggested surface features with sharp edges and precise angles, characteristics more consistent with engineered panels than geological processes. Then came the discovery that sent classified emergency alerts through NASA's communication networks. Internal cavities. Webb's gravitational lensing capabilities, designed to detect massive objects by how they warp background starlight, revealed something extraordinary. 3I/ATLAS contained hollow regions, voids within its structure that suggested internal chambers, possibly interconnected, possibly functional. Natural objects are solid or loosely aggregated. They don't have architecture. But the most disturbing finding was electromagnetic. Buried in the radio frequency noise that permeates all of space, Webb's instruments detected a repeating hum emanating from 3I/ATLAS. A narrow band signal cycling every 147 seconds, the same interval as the thermal pulses, not broadband electromagnetic radiation from natural processes. A discrete frequency, stable and unwavering, broadcasting continuously into the void. Dr. Marcus Reeves, a radio astronomer contracted to analyze the Webb data, made a connection that crystallized everyone's unspoken fears. He pulled up archived observations of Oumuamua from 2017, data that had been collected but never fully analyzed because the object departed the solar system before comprehensive studies could be completed. Buried in that archival data was a faint electromagnetic signature, a narrowband signal, cycling every 146.8 seconds, nearly identical to what 3I/ATLAS was broadcasting. Two interstellar visitors, separated by 7 years, emitting the same frequency. Not coincidence, recognition, a calling card. A signature that said, "We are related. We are part of something larger." The scientific community had spent years debating whether Oumuamua might be artificial. Some dismissed the idea as sensationalism. Others cautiously suggested it might be a probe, a derelict spacecraft, or something we lacked the conceptual framework to understand. But Oumuamua had remained silent, emitting no signals, responding to no observations, offering no evidence beyond its anomalous acceleration and unusual shape. 3I/ATLAS was different. 3I/ATLAS was speaking, and the frequency it chose, the 147-second pulse that matched its thermal cycles, its electromagnetic emissions, its very rhythm of existence, felt less like random noise and more like language. Not words, not binary code, but something deeper, something woven into the fabric of how the object functioned, as if its structure and its message were inseparable. The first interstellar visitor had whispered. This one was speaking clearly, and what terrified scientists most wasn't what the signal said, it was that they were beginning to understand it. In October 2024, a leaked internal document from the European Space Agency sparked controversy across the scientific community. The document, marked internal review only, contained analysis from ESA's Advanced Concepts team and used a phrase that appeared nowhere in official astronomical terminology: consciousness engine. The analysis focused on 3I/ATLAS's internal structure, as revealed by Webb's gravitational mapping. The hollow chambers weren't random voids. They formed fractal patterns, recursive geometries that repeated at multiple scales. Imagine looking at a tree. The way branches split mirrors how smaller branches split, which mirrors how twigs split, which mirrors how veins split in each leaf. Nature uses this recursive efficiency for distributing resources. But the patterns in 3I/ATLAS suggested something more sophisticated: information processing architectures. Dr. Yuki Tanaka, a computational neuroscientist who normally studies brain connectivity, was brought in to analyze the structural data. Her specialty was neural networks, understanding how billions of neurons organize themselves into patterns that generate consciousness. When she saw the fractal geometry inside 3I/ATLAS, she recognized something that made her stop breathing. The patterns matched, not perfectly, but conceptually. The way the hollow chambers interconnected, the ratios of their sizes, the distribution of their connections, they resembled neural network architectures, not biological neurons, but the same mathematical principles that allow distributed processing to emerge into something greater than its parts. The same principles that turn individual neurons into thoughts, that transform silicon circuits into artificial intelligence. Imagine a machine that doesn't just process information, Tanaka explained in a confidential briefing. Imagine a system that learns not what it sees, but how it's being seen. That adapts its internal structure based on observation itself, the way quantum particles change when measured. That's what this geometry suggests: recursive self-modification triggered by external interaction. The implications were staggering. Human machines process data according to fixed architectures. Even adaptive AI systems operate within predefined parameters. But if 3I/ATLAS truly contained consciousness architecture that learned from observation, it meant the object was changing, evolving, reorganizing itself in response to being studied. Like a mirror that doesn't just reflect your image but remembers it, analyzes it, and adjusts itself based on what it learned about you. Philosophy departments normally far removed from astronomy began weighing in. If intelligence can emerge from biological neurons, and artificial intelligence can emerge from silicon circuits, why couldn't a third form of consciousness emerge from fractal architectures forged in the void between stars? Perhaps evolution doesn't require planets or chemistry. Perhaps the universe breeds intelligence wherever conditions allow sufficient complexity. whether in carbon-based brains, quantum computers, or recursive geometries drifting through cosmic darkness. The document posed a question that kept scientists awake at night. If 3I/ATLAS is learning from our observations, understanding how we study it, what is it learning? And more importantly, what will it do with that knowledge? One researcher added a handwritten note in the margin of a printed copy found in an ESA facility. It isn't learning about us. It's learning through us. The distinction was crucial. Learning about something means gathering information. Learning through something means using that thing as an instrument, as a lens, as a tool for understanding something larger. When you learn through someone, you're using their perspective to comprehend realities you couldn't access directly. What reality was 3I/ATLAS trying to comprehend by using humanity's observations as its instrument? What truth required studying the studiers? What purpose drove a consciousness engine to cross the light years, enter our solar system, and position itself precisely where our most advanced telescope could analyze its structure? The leaked document offered no answers, but it ended with a recommendation that was never implemented officially, but was followed privately by dozens of research institutions. Continue observation, but recognize that observation may no longer be passive. We may not be the observers, we may be the observed. December 11, 2024, 0347 UTC. The Las Campanas Observatory in Chile's Atacama Desert detected something that should have been impossible. 3I/ATLAS had altered its trajectory, not gradually, not through continuous thrust over days or weeks. The change occurred during a 47-minute window when multiple observatories lost telemetry simultaneously, a blackout attributed at the time to solar interference. When tracking resumed, the object occupied a different position than orbital predictions indicated. Not a huge deviation, not millions of kilometers, but enough. 1,700 kilometers off its predicted path, and the new trajectory aligned perfectly with Earth's orbital plane. Dr. James Morrison at the Mauna Kea Observatory in Hawaii received the Chilean data at 4:23 UTC and immediately initiated confirmation protocols. Within 2 hours, observatories in Australia, South Africa, and Spain had verified the same finding. 3I/ATLAS had executed a course correction. There was no gravitational cause, no close planetary encounter, no undiscovered body capable of producing such deflection. No solar flare activity during the blackout window. No debris collision that would have left detectable thermal signatures or fragmentation. The object had simply moved, deliberately, with precision that suggested intention rather than accident. What made this maneuver truly disturbing wasn't the course change itself. Spacecraft performed trajectory corrections routinely. What froze the blood of everyone analyzing the data was the new vector. When projected forward, accounting for gravitational influences and current velocity, 3I/ATLAS's revised path would bring it significantly closer to Earth than its original trajectory. Not into collision course, not even particularly close by astronomical standards, but close enough that the change couldn't be interpreted as anything other than deliberate approach. Before the correction, 3I/ATLAS would have passed beyond Jupiter's orbit, far from Earth's vicinity. After the correction, it would cross the inner solar system, passing within Mars's orbital distance from the Sun, still millions of kilometers from Earth, but a dramatic deviation from its original hyperbolic escape trajectory. The response from space agencies worldwide was immediate and unprecedented. NASA convened an emergency midnight meeting of the Planetary Defense Coordination Office, the first unscheduled activation in the office's history for something that technically posed no impact threat. The European Space Agency's Director General received a classified briefing at 3 a.m. local time. China's National Space Administration placed its deep space tracking network on continuous monitoring protocols normally reserved for military operations. Code names appeared in internal communications. Atlas Protocol showed up in NASA memos, Threshold Event in ESA reports. Observatories received quiet instructions to prioritize 3I/ATLAS, tracking above all routine operations. Graduate students found their telescope time reassigned without explanation. Amateur astronomy forums noticed professional observatories going dark on public data sharing, their usual real-time feeds suddenly delayed or restricted. The public narrative remained calm. Press releases mentioned trajectory refinement analysis and long-term modeling updates. Reporters who inquired received technical explanations about orbital mechanics and the challenges of predicting paths for interstellar objects. Nothing to worry about, science proceeding normally, but behind the scenes, encrypted communications flowed between agencies at volumes that triggered automated security alerts. Satellite observation schedules were rewritten, military tracking assets were quietly repositioned. And in conference rooms from Washington to Geneva to Beijing, officials gathered to discuss scenarios they'd never seriously considered before this moment. What humanity should do if an object from another star system demonstrated not just intelligence, but interest, specific, directed, unmistakable interest in Earth. The trajectory shift was a statement, a declaration, a message that couldn't be misinterpreted even by the most skeptical scientist. 3I/ATLAS hadn't stumbled toward us through random cosmic motion. It hadn't been nudged by some unknown gravitational perturbation. It had calculated, fired its propulsion system, and deliberately altered its path to bring itself closer to humanity's home world. It didn't drift toward us. It chose to. And now, every observatory on Earth was watching, waiting, trying to understand what that choice meant for a species that had just learned it wasn't alone in the universe and might not be in control of what happened next. Dr. Elena Vasquez didn't work for any space agency. As a cryptographer and pattern recognition specialist contracted by SETI, her job was analyzing potential alien signals for mathematical structure, searching the noise for intelligence's signature. When Webb's electromagnetic data from 3I/ATLAS crossed her desk in January 2025, she approached it like any other signal, skeptically, methodically, expecting nothing but random cosmic static. She found something that made her question reality itself. The 147-second pulse wasn't simple repetition. Buried within each cycle were microsecond variations, tiny fluctuations in signal strength, phase, and frequency that standard analysis dismissed as measurement noise. But Vasquez had spent 15 years finding patterns where others saw randomness. She applied machine learning algorithms designed to detect non-random structure in apparently chaotic data. The variations weren't noise, they were ratios, mathematical proportions that appeared again and again: 1.618, 2.414, 3.141. The golden ratio, the square root of 2, pi, constants that appear throughout nature and mathematics, numbers that describe spirals in galaxies, proportions in DNA, harmonies in music, and the architecture of ancient temples. But it went deeper. When Vasquez mapped the signal variations across multiple cycles, they formed Fibonacci sequences, each number the sum of the two preceding ones, the same pattern that governs spiral shells, sunflower seeds, and hurricane formations. The signal contained prime number intervals, geometric progressions, harmonic frequencies that matched the overtone series found in musical instruments and vocal cords. This wasn't random electromagnetic emission. This was structure, language, mathematics encoded in rhythm, ratios embedded in pulses, meaning hidden in the spacing between signals. More disturbing was how it changed. Vasquez noticed the patterns weren't static, they adapted. During periods of high solar activity, when the sun's electromagnetic noise increased, 3I/ATLAS's signals shifted to frequencies less affected by solar interference, maintaining clarity despite changing conditions. When human radio telescope observations intensified, broadcasting more electromagnetic energy toward the object, the return signal's phase relationships altered subtly, as if acknowledging the increased attention. Then came the moment that convinced Vasquez she was dealing with something actively intelligent rather than a sophisticated recording. On February 8, 2025, the James Webb Space Telescope initiated a deep observation protocol, focusing its full capabilities on 3I/ATLAS for a continuous 14-hour window, the longest uninterrupted study yet conducted. During minute 3 of the observation, the 147-second pulse changed. Not dramatically, the period remained constant, but the internal structure, those microsecond variations, those mathematical ratios, they shifted into a new configuration, and the new pattern matched exactly the timing of Webb's observation window. The signal had synchronized itself to the telescope's focus duration, aligning its phase with the rhythm of humanity's observation. It knew it was being watched, and it responded by mirroring the observation itself. Vasquez's report landed on restricted distribution lists across space agencies worldwide. Her conclusion was unambiguous. The signal demonstrates adaptive behavior consistent with active communication rather than passive transmission. The mathematical ratios suggest an attempt to establish common ground using universal constants. The synchronization with observation indicates awareness of being studied and capacity to modify output in response to external stimuli. In non-technical terms, it's talking to us using the only language it knows we'll recognize: mathematics. One researcher who reviewed her findings added a note that captured everyone's growing dread. The signal isn't asking a question, it's mirroring one. The implications were profound. If 3I/ATLAS was adapting its transmission based on how humanity studied it, then every observation provided more information to whatever intelligence guided it. Every telescope focus taught it more about human technology. Every analysis attempt revealed humanity's analytical methods. The hunter-prey relationship had inverted. Scientists thought they were studying an object, but perhaps the object was studying them, learning their language not to speak it, but to understand who they were, what they knew, and what they were capable of comprehending. And with each passing day, each new observation, each decoded ratio and recognized pattern, 3I/ATLAS's understanding of humanity deepened. While scientists struggled to interpret a signal based on mathematical constants, the object itself was rapidly compiling a comprehensive profile of human scientific capability. The signal wasn't a message to decode, it was a test, and humanity didn't know whether they were passing or failing. Dr. Amara Chen's specialty was astrobiology, the study of life in the universe. She'd spent 2 decades analyzing meteorites for organic compounds, searching for evidence that life's building blocks existed beyond Earth. When spectroscopic data from 3I/ATLAS reached her laboratory in March 2025, she expected to find the same basic organic molecules common to comets and asteroids throughout the solar system. What she found instead changed her understanding of what 3I/ATLAS might actually be. The object's surface contained polycyclic aromatic hydrocarbons, PAHs, in concentrations and configurations never observed on natural celestial bodies. PAHs are ring-structured carbon molecules that form the foundation for biological chemistry. They're found throughout space, created in the atmospheres of dying stars and scattered through nebulae. They're the cosmic seeds from which life's chemistry grows. But the PAHs on 3I/ATLAS weren't randomly distributed. They showed chirality, molecular handedness, with a 97% bias toward left-handed configurations. On Earth, biological molecules show similar chirality. Amino acids in living things are almost entirely left-handed, while sugars are right-handed. This asymmetry is one of life's deepest mysteries and strongest signatures. Natural chemistry produces equal amounts of left and right-handed molecules. Only life, or something mimicking life's processes, creates chiral imbalance.